Okay, so here is the study guide for Unit 5 or Unit 6. Is it Unit 6 or 5? But it's on waves. Okay, so the first one says define waves and name the two main categories of waves. So waves are, what would be the answer? Two categories, I know that one. Two categories are transverse and longitudinal. Waves carry energy. Okay, what type of waves do not need a medium? So a medium, I know, is something that it travels through. So which type of waves do not require medium? I remember we did a warm-up on what if a meteor strikes the moon, and I remember that transverse waves you can see, but you couldn't hear them. So transverse is another word for light waves. So in my brain, I remember that transverse are light waves, and they don't need a medium, so they can travel through outer space. Sound and light travel at different speeds through different mediums. List the order from slowest to fastest for sound waves and light waves. So in some of the classes, we haven't done as much with the light, but I know we did this with sound. We watched a little tiny video on that train where it said, hello, and we knocked on the desk. So sound waves, if I remember sound waves, slowest is a gas, which is air. So order from slowest to fastest. So this is the slowest, medium, so sound, and I'm going to write fastest. And I remember like when I knocked on the desk. Light waves are the opposite. Light goes slowest through a solid, and if you've done the lab, you'll see that. Then a liquid, and it goes the fastest through a gas, like through air. What property determines the speed of the wave? We did a graph on that. Okay, I'm in a group. I'm not sure if anybody's going to call on it. It's how thick it is. It's really the density. The property determines a speed of a wave is density. What are two names of wave movements? Draw a diagram each of the wave and label the parts of both. So I think this is the rest line. So I've got my two waves, so I know them now. They're transverse and longitudinal. Again, I'm just going to say it over and over. Transverse are my light waves. These are my sound waves. Okay, the question says, what are the names of the movement? Transverse are that T right there helps me to remember that it moves perpendicular. Perpendicular, which is a math term. These two L's, I've got an L here and an L there to help me remember that they move parallel. So a longitudinal wave is going to look like this. There's my compression, and it spreads out. It rarely happens, and then it compresses again. So this, when it's compressed, this is my compression. This here is my rarely happens. This is my rarefaction. If I were to label a wavelength, I would start. I could start from the beginning or the end. Let me start from the beginning of this compression and go to the beginning of this compression, and that would be a wavelength in a longitudinal wave. Transverse waves go perpendicular to the rest point. I had to draw it again because I wrote so much. This top part is the crest. Crest is the top. I always think of like Crest toothpaste, the top selling toothpaste. This down here is my trough. Farm terms, like what pigs eat out of that trough down there. So that's kind of like where they put all their food. If I were to measure a wavelength here, I could go from the top to the top, or I could go from the bottom, a trough to a trough. Either one, this is a wavelength. When we first took notes, we did a wavelength as one corresponding point to the adjacent, which means the next closest. So that's what a wavelength is. It goes from one adjacent point to the next. There's one thing I didn't add. This part here is amplitude. And wavelength and the parallel and longitudinal, we don't talk about that. So just you have to know what it is. Okay, as the wavelength increases, so I always get confused on this. So I'm going to, as the wavelength increases, what happens to the frequency? Frequency means how often something happens. So as the wavelength, so let me start with a tiny wavelength, and then let me increase it. That's what that question is asking. As the wavelength increases, the frequency, I have fewer wavelengths. So my frequency decreases. But sometimes I need to draw that to clarify. So here is a short wavelength, here's a long wavelength. Okay. What is and isn't transferred? The only thing that is transferred along a wave, either a longitudinal wave or a transverse wave, is energy. Either sound energy or light energy. What's the difference between rarefaction and compression? Compression wavelengths are close together, and a rarefaction wavelengths are spread apart or spread out. I'm just going to do spread. Oops. And again, here's my wavelength. This wavelength, they've actually marked it in the middle, but they're going from the middle of one compression to the next corresponding, the next adjacent corresponding same point. How does matter respond to energy in a transverse wave? This is not on the test, so I'm going to leave that blank. We don't need to do that one. Oh, actually, how does matter respond? Maybe what they mean is transverse wave, because the matter stays there, but the energy, I'm going to clarify. I think that I mean energy moves transverse perpendicular, and here in a longitudinal wave, energy moves, those two L's are there to remind me, parallel. So what is the best part of a wave? So if I were comparing waves, what would I look at? What is the best part of the wave to use to compare the energies in different waves? The best part, so that I could tell, so like in the electromagnetic spectrum, if I'm looking to see, to identify a wave, I would look at the wavelength. Since wavelength and frequency is corresponded, I could also look at the frequency. And I would know the difference between those waves. The shorter the wavelength, again right here, the shorter the wavelength, the shorter the wavelength, the higher the frequency. Also, the longer the wavelength here, the lower the frequency. So that's kind of the third question, second or third question on that. So I know that's on the test. Of course, anything that's on here except for maybe 8 and 9. So list the electromagnetic waves in order from shorter wavelength. Oh, this is the opposite of how I usually show it to you. Higher frequency to longer. Well, the mnemonic that teacher gave me was I'm going to have to do it backwards because I know that radio waves are long and slow. So this is Ronald McDonald is very ugly and extra greasy. And then from there, I know that the G is gamma, X-ray, ultraviolet, visible, infrared, microwave, and radio. And I know that this has the least energy, this is the most, and I can tell the difference because of their length, their wavelength, and their frequency. Okay, let's look at the back. Define the visible spectrum. Oh, so this is about the electromagnetic spectrum. So I'm talking about my EMS. The visible is the part of the EMS that we see. I remember from the poem, the line is, I remember Roy G. Biv, which stands for red, orange, yellow, green, blue, indigo, violet. And just like the EMS, the red is my longer waves, my violet is my shorter waves. Oh, list the colors of visible light from greatest to least. I just did that. So Roy G. Biv. And greatest, oh, it says greatest to least. Well, this is my longest wavelengths. So my greatest energy would be backwards. V, I, B, G, Y, O, R. Because I know the shorter the wavelength, the more energy. So if this question says the list from greatest energy, so it's flipped. Okay, which value has the longer wavelength? So which wave has the longer wavelength? The shorter frequency. So again, I'm going to look at Ronald McDonald is very ugly and extra greasy. So here's radio and here's gamma. Which one has a shorter? Which value has a longer, that's wrong, has the longer wavelength? The longer wavelength is radio because it comes first. Which one has a longer wavelength? Infrared or visible? The longer the wavelength is, here is my infrared, X-rays, or ultraviolet. Ultraviolet has longer wavelengths. So again, when I see 3 questions like that, I should be able to compare. So again, I'm looking at these waves and comparing the wavelength. Which types of electromagnetic radiation are humans able to detect? So detect is like, I think of my 5 senses. Like which ones would I interact with? So visible, it's the colors that we see. And back to that poem that I know everyone memorized. Let's see, visible light. We do not see infrared, but we feel this heat instead. So I can feel the heat. And that's it. I don't detect any of the others. How do we protect ourselves from ultraviolet rays? Ultraviolet rays can burn. Put on sunscreen, or you'll learn, which is also the reason we wear sunglasses. They both protect from UV rays. What's the smallest part of the electromagnetic spectrum? That was a homework we went over last class. Visible light. Of all of those sections, it's the smallest one. How is music transferred from speaker to your ears? Well, I know it starts with longitudinal waves, vibrate in the air or through the air to my ear. Ears, to capital letter. Longitudinal waves vibrate in the air to my ears. Ah, now we're back. We're talking more about sound. What's the difference between sonar and echolocation? Sonar is a man-made sonar is man-made technology, or I should say just, I guess I could just say sonar is technology that submarines use, and echolocation is used by bats and dolphins, and also sharks, but those are, and other animals. But echolocation is animals, sonar is man-made submarines. So now we're talking about longitudinal waves. The colors and everything was electromagnetic spectrum. Those are all transverse. These are all sound. How do bats, whales, and dolphins communicate? That's right there. They use echolocation. It echoes, it bounces back. Okay, what happens when light travels through a prism? So we're doing this in the lab, so light comes in and then it bends, it refracts, and it separates it into all of the colors of the rainbow. So light bends, and a vocab word that will be on the test is, it's called refracting. And it separates white light into, I'm going to go Roy G. Biv, into all the colors of the rainbow. So refracts is going to be is a vocabulary word. It's brand new. We're just learning it the day before the test. Okay, what happens when light travels through diffraction? It's the same thing. Light is separated into colors of the rainbow. This is not on the test. Pretty sure, but this is. Okay, draw a picture of light bouncing off a surface. Bouncing off. We did a little activity on that. Bouncing off a surface. What is this called? Bouncing is reflecting. Bouncing equals reflecting. Sound also bounces, but so does light. So bounce is reflect. That's a vocab word to know. Label the angle of incidence and the angle of reflection. So if you did the Ed puzzles, I know that when the light is going in and the light goes out, so this is, and I have the arrow so I can see, angle of incidence and it equals. So if this is a 45-degree angle, this must be a 45-degree angle. And this is called the angle of reflection. And this is because of the law of reflection, which is kind of cool. That's why if you stand in front of a mirror with a light, it bounces the same angle. Okay. How does light pass through a concave and a convex lens? So that was on the Bill Nye. So concave goes in. It's a light that goes in, and convex goes out. So this is my concave lens. So if the light is coming in this way, kind of like it to be this way too. The light separates out like that. This is like a magnifying glass. Yeah, it actually is like a magnifying glass. Magnifying glass. So this is what my lens looks like. If the light goes here, it brings all the light together. And so that image looks sharper. Okay, so when the light goes in here, it brings it together. Light here, it separates it out. Okay, what is resonance? I know you guys all know this. We're going to draw this. Here's my tuning fork. Here's another oop. I'm not a good tuning fork. They're the exact same pitch. So if I hit this one, the sound is going to travel and make that one make noise too. So resonance is when sound, I'm going to say copies. Resonance when sound copies. Okay, let's just leave it. But that's why this tuning fork will make a sound even if I don't hit it, because it picks up and copies it. Okay, I think that's it. I would, if you get your study guide done early, I would make flashcards of those vocabulary words.